Hi, I'm Graham Steele, CEO and founder of Cryptosense, and today I'm going to answer the question, did a cosmic ray just zap the certificate transparency log? So if you're a subscriber to the channel, which you should be, you'll know that the certificate transparency log is essentially an append-only list of SSL certificates that have been issued by the major CAs, and it's checked cryptographically so that it can't be tampered with. So in that video where I explained the CTL, I talked about the certificate transparency log, but in fact there are several certificate transparency logs. There are more than 20. They're operated by large companies like Cloudflare and Google and large CAs like DigiCert, and user agents or browsers to you and me can choose to check as many of these CTLs as they want to check that the certificate that they're looking at is the right one. So if I point my browser at example.com, using TLS, and so there's a certificate for example.com. If I'm using Safari or Chrome, they'll typically check that at least 2 of the CTLs have my certificate in it to be sure that it's a legit one, and then they'll carry on. So that's all good. Now, on June the 30th, a guy called Andrew Ayres wrote an email to the Certificate Transparency Log policy discussion group saying that a particular log called YETI 2022, which is operated by DigiCert, was in an inconsistent state. That's to say that its hashes weren't checking out anymore, so it looked like the log had kind of been tampered with. And they were able to trace this back to a certificate added on June the 29th. And what had happened, in fact, was that while calculating the hash for a legitimate new certificate to add to the log, a single bit had been flipped in the calculation, and this resulted in the incorrect calculation, and then we carried on adding more certs afterwards, and it wasn't until this inconsistent state was spotted that we realized that something had gone wrong. And there seems to be, seeing it as this same piece of code and the same hardware have been calculating these hashes all the time that YETI 2022 was running without any trouble. Rather than this being a bug, it was actually just a random bit flip. So random bit flips do happen in computer systems. One of the things that causes them is cosmic rays. So for example, gamma radiation striking a chip while a piece of semiconductor while it's calculating. And for example, if you're going to send computers up into space in satellites and so on, you have to calculate a reasonable probability of this happening and make sure your systems are able to cope with that. Because once you're outside the atmosphere, these things happen a lot more often. But also other things can cause occasional glitches or random flips to happen. So this random flip has happened. In fact, because of the way that you can't tamper with a log, you can't go back and rewrite it, they had no choice at DigiCert but to turn that log off, just to say, okay, we're not going to add any more certificates to that now. It's now not a legit log to go ahead and use. So like I said at the beginning, this doesn't matter too much because there's more than 20 of these CTLs running, and so browsers are able to use other ones, and so we're all still fine. So even though a cosmic ray really did, or something really caused a bit flip in this calculation, this has not destroyed the integrity of the CTL, so you can continue to browse the web in safety, and we're all fine. One question that came up after this happened was, well, there are other hash-based append-only logs out there which are very important. For example, in blockchain-based cryptocurrencies, more or less the same kind of thing is happening. So since there's this decent probability of a random bit flip, could it happen that this bit flip happens and let's say the Bitcoin blockchain breaks and we can't verify transactions anymore because we're in an inconsistent state? So the answer is no, that can't happen because Bitcoin is designed and blockchains generally are designed a slightly different way. They have a consensus mechanism, and when somebody suggests adding a chain with a hash that goes with it, there are validators who will say, I'm going to check that the hash is correct on that. And in this case, unless they all had exactly the same cosmic ray strike exactly the same bit and have exactly the same flip, this would have been called at this error at this time, and so we would never extend the chain with that block with the bit flip in it. So that's a different way to design against that kind of possibility. So the upshot of this is you can still trust the CTL. You don't need to worry about blockchain having the same problem, or not. It's going to be able to cope with that problem if it should have it. But if you do design hash-based append-only data structures for some other purpose, you need to bear in mind that this probability, if you're going to calculate that much hashes, eventually you might have this kind of flip, and you need to have a way to recover from that. So subscribe to Cryptosense channel here, and you'll keep up to date with all the news about applied cryptography, and I hope to see you again here soon for another video.